So there's multiple ways to do it. One of the ways, and the most used way, is using rectangles. So we can use the sum of the area of the rectangles to approximate the area under the curve. Now, it is important this is an approximation. It's not 100%. The more rectangles we have, the more accurate the approximation for the area is. If you only have 2 rectangles, it's not going to be as accurate as if you had 10 rectangles. Now, there are some sort of symbols here that we need to get your head around. The first is what we call the integral symbol, and it looks like an S because it stands for the sum of rectangles. Now, we have the indefinite integral, which has no limits. So it's the sum of the rectangles for some sort of function x. Now, we have a definite integral, which has a range. It has set limits of x equals a and x equals b. And these are shown on this sum symbol there, the integral symbol. Now, rectangles are not the only way we can find approximations for areas under the curve. We can use squares, which you can see here, and we have the area of a square is base times height, so you would have a rough estimation of how much area or how many squares this is taking up. The next is a triangle, which is the half base times the height, and you would draw a rough triangle over it, lapping it, and then use your x and your y coordinates to find your base and height and find an estimation for the area there. An alternative way that is almost as popular as rectangles is trapeziums, where you have the half h bracket a plus b, where you can see a is the lowest side, b is the taller side, and h is the width between the 2 points. So we're going to jump in and do some questions because it might help you understand this a little bit better. So we need to find an approximation to the area under the curve y equals x squared plus 2x between x equals 1 and x equals 2 by using 2 inner rectangles. Now, it's important to note that if we had a graph here and we have x equals 1 down here and x equals 2 here, if we were trying to make 2 rectangles in here, we would need to have something like this. Alright, so here's our rectangles. Let me do them a little bit better. Going across here like this. Alright, so we need to know the height for that 1 and the height for that 1.5. Okay, so it's important to note that. So if we have between x equals 1 and x equals 2, we know we have 2 rectangles, and the width of each rectangle is going to be 0.5. So we have the start of one rectangle at x equals 1 and the start of the other rectangle at 1.5. Now that we've done that, we need to find the y values or the height for these points. So we know we have y equals x squared plus 2x, and if I say that x is going to be 1, I get 1 squared plus 2 times 1, which gets me 3, and then if I have 1.5 here, I get 1.5 squared and that gets us 5.25. So in reality we have 2 triangles here, sorry, 2 rectangles. So we have our first, and then we have another one over here. These are not to scale, and 5.25. So we need to find the area for these two and add them together. So the total area here is going to be 0.5 times 3 plus 0.5 times 5.25. And that gets us 4.125. Now, we weren't given units, but you should always write units squared because it is an area. So we'll look at the next one, and this time we're using a trapezium. So we have our function, and it's between x equals 0 and x equals 4. So we need to find our y values here, the heights, and this is going to be our a and our b values. So we need to find y for each of these points, and again these are going to be a and b. Alright, now this can be our a value, and then our b value will be 65. Alright, so essentially what we've got going on is a trapezium that looks like this. There's a distance between here because we know this is 0 and this is 4, so there's 4. We know the height of A was 1 and the height of B was 65. So if I label those, we have A, B, and H. Now we use our formula. So the area of a trapezium is H over 2, A plus B. We just substitute in our values, so 4 over 2, 1 plus 65. Put that in a calculator and you get 132 units squared. So that's the approximation of this curve. So to recap, remember you've got the integral symbol, which is that S. You have two types. You have indefinite, which has no limits, and definite, which has a set range between two x values. We can use rectangles, as you can see on the screen, to approximate it. We can use squares, we can use triangles, and finally we can use a trapezium. Each of these can be used to represent or find the approximate area under a curve.